Norvell again, coming to you live with our continued reading of How Racism Has Changed the Human Brain by Joseph R. Gibson. The primary functions of emotions is to promote survival. Emotions are associated with areas or structures in the brain that focus our attention on the threat, prompt, or motivate specific survival-oriented actions and determine the threatening implications of the external circumstances of our lives. Peter Lang and others explain that emotions are considered to be actions, dispositions. It is held that effects evolved from reflexive overt reactions to appetitive or evasive stimulation that served immediate survival functions, e.g., the Nutorrent's sexual approach, fight or flight. That's what he has here. Nutorrent's. Okay, let's look that up here. That's a new one on me, actually. I'm pretty sure I looked it up before when I read the book, but it's nothing that I committed to memory. It basically means emotional and physical nourishments. So it has to do with nutrients. Nutorrents. Sexual approach, fight, flight. Let's just start that sentence over. It is held that the effects evolve from reflexive, overt reactions to appetitive or aversive stimulations that served immediate survival function, e.g., the Nutorrent's sexual approach, fight, flight. The neural mechanisms for these functions are preserved in the human brain in the subcortical and deep cortical structures and are the foundations of human emotions. Expressed emotions developed from primitive actions that facilitated the survival of species and individuals. In man, the evolved effects are best categorized as motivationally tuned states of readiness. Although emotions may come in many forms, their fundamental organization is motivational. The most active and plastic structures of our survival-oriented brain is the amygdala. When we perceive threat and proceed to become stressed or afraid or anxious, the neurons in our amygdala are activated far more than any other brain structure. The more we stress and fear, the larger and more sensitive or dominant our amygdala or amygdalae, there's actually two, become. Neuroscientists have consistently confirmed this association by the use of a brain scanning method called functional magnetic resonance imaging, or fMRI, which uses a huge donut-shaped magnet to capture video of neural changes occurring in our brain. Functional neural imaging visibly shows that the neurons in our amygdala are especially activated whenever we will recognize anything or anyone explicitly or implicitly threatening. The amygdala is largely responsible for the aforementioned fight or flight or stress response. The stress and emotions necessary for our survival originate from the amygdala. Throughout and emanating from the amygdala is ancient neural circuitry specifically designated to alert us to threat, and the reflexively initiate the relatively efficient emotional and behavioral response to it. Let's go read that again because I had to turn the page and it didn't flow didn't sound like I wanted it to sound. Throughout and emanating from the amygdala is ancient neural circuitry specifically designed to alert us to threats and reflexively initiate a relatively efficient emotional and behavioral response to it. It is the amygdala that makes us afraid or anxious of physical and psychological danger. Without this fear or anxiety, we couldn't be adequately motivated to protect ourselves. With adequate motivation, we think and react in ways that reward us and our species or social groups via sustained survival. Reward is crucial to most human behavior, explained Rebecca Elliott and Bill Deacon. I will quote them. We do not act aimlessly for no reason. Rather, we do things that will achieve outcomes that we need or want, or to avoid outcomes that would be harmful or unpleasant. The vast majority of our behavior is motivated by either obtaining rewards or avoiding punishments, especially death. Now, being that we read earlier that the brain is it's a survival thing, and it operates on wanting to keep us alive. So anything that the brain feels is harmful to us, it's going to go against it and try to keep us alive. Accordingly, specific neural structures, including the amygdala and pathways, collectively referred to as the reward system or reward pathway, emerged over the course of human evolution. The reward system is neural circuitry that, when repeatedly activated, reinforces certain thoughts and behaviors. Its primary function to make us feel good by releasing neurotransmitters, dopamine via special neurons when we engage in survival-oriented thought and behavior. The reward of feeling good reinforces the thoughts that behaviors necessary for our survival. By reinforcing, I mean that it increases the probability of the recurrence of survival-oriented thoughts and behaviors by strengthening the corresponding neural structures and pathways, as well as releasing dopamine, which facilitates the brain's functioning, especially under a survival orientation. Survival becomes our brain's number one priority. Every thought, observation, memory, emotion, motivation, action, and overreaction becomes most likely based by this hardwired focus on survival. Excuse me, let me grab something for the throat. The association between memory, emotions, current thinking, or cognition and behavior is particularly important in the reward system and the repetition of survival oriented thought and behavior. The reward system motivates humans to repeat survival oriented thought and behavior by connecting via increased neural circuitry to the brain regions and control memory, emotions, cognitions, and behavior. This connection, along with concurrent releasing of dopamine, enables the brain to intuitively create the emotional memory that prioritizing survival oriented thought and behavior will make you feel good. This increases the likelihood that you will prioritize survival oriented thought and behavior habitually. The more you express this priority, the stronger the neural circuitry within the now survival oriented reward system becomes, and the more likely you will continue to think, feel, and react in ways particularly designed to maximize your chance for survival. The neural circuitry collectively used by the stress response and the reward system is the most employed and, as a result, strongest and most efficient neural circuitry in our entire brain, which is why it can be deduced that the human brain is survival oriented. Excuse me. Some honey and tea here for the throat there. Professor Eric Jensen, to whom I owe my initial understanding of interest in the impact of chronic stress on neuroplasticity, wrote in Teaching with Poverty in Mind that our brain adapt, i.e. to changes, to survive our circumstances. Neuroscientists are continually identifying just how malleable the brain is as it enables us to perceive, plan, problem solve, rationalize, emote, act, interact, react, overreact, remember, repress, rebel, internalize, fear, doubt, acquiesce, and all things in between. If it hasn't become glaringly obvious yet, I fully concur with the psychoanalyst Norman Doge's claim that the human brain can change itself. In fact, according to Jensen, our brains are designed to change because they possess plasticity. Thanks to neuroplasticity, the human brain can literally change and be remolded intentionally and unwittingly, like plastic. Neuroplasticity makes it possible for our brain's 1 billion interconnected neurons to continuously recreate or rewrite neural pathways and modify neural structures throughout our lifetime. The catalysts for neuroplasticity are our novel or sustained thoughts, emotions, memories, reactions, and experiences. Whenever we have a new chronic experience or thought, specific neurons are activated, neurotransmitters are released, new neural pathways are formed, or pre existing pathways are reinforced, and associated neural structures are functionally or structurally altered. Despite the survival-oriented intent of these changes, neuroplasticity can ultimately be either beneficial or maladaptive. Now, this is the key. This is what I was bringing uh, to mind in the previous live. You either have beneficial actions or you have maladaptive actions that are destructive to the person. And when you're stressed, your brain reacts without being able to reason. And the science knows this, the scientists and the psychoanalysts, they all know this. That's why when some people get angry, just like the Hulk, you can't think. Your thinking turns off. Your ability to reason turns off. Chronic experiences or thoughts, especially those that are emotional, are more likely to produce brain changes that become quasi-permanent. Recurring thoughts, emotions, and experience become patterned neuronal activity, i.e., neural circuitry, that can cause us to begin responding to the circumstances of our lives automatically based on these established neural activations, patterns, i.e., brain changes. What we typically refer to as learning, i.e., long-term memory development, is actually neuroplasticity. Learning occurs as connections between neurons, neural pathways, and neural structures are strengthened or modified through emotional impact or repeated experience. In addition to changing our behaviors, learning literally changes the structure design of the brain, the structural design of the brain. Psychosocial forces, especially psychosocial stress, are the most influential with regards to neuroplasticity. The human brain, explained Arnulf Kolstad, another scientist, adjusts to the environment. This is a quote from him. The human brain adjusts to the environment, the social situation, and to the psychological reactions. So he's saying your brain adjusts to whatever situation you find yourself in, a social situation or psychological reactions. The brain develops new capacity as a result of our experience, our physical and mental activity, and how we cope with the situation. It stores what happens and creates new ways of thinking, feeling, and behaving. This quality of the brain is due to the plasticity or ability to develop and change. Physical and mental activity produces structural changes in the brain due to the brain plasticity in humans. The interconnections between neurons are changing all the time, and the brain structure is more like the software. This explains the importance of social cultural influences since experiences are internalized and stored in the brain as pattern neuronal activity. It was easier for me to accept the impact of our experiences on neuroplasticity than it was to accept that our mere thoughts can have the same impact. It was just more reasonable for me that the more we did or experienced something, the more our brain structurally changed to wire it in. Nevertheless, our thoughts or cognition, particularly when these thoughts are repetitive or emotional, create neural connections and change the neural pathways and structures associated with processing what we are thinking about. Just like, and sometimes even more profoundly than our experiences. To quote Joe Dispenza, whether we like it or not, once a thought happens in the brain, the rest is history. The input the brain receives from thoughts changes the brain instantly. Read that again. It's very important. Joe Dispenza, whether we like it or not, once a thought happens in the brain, the rest is history. The brain receives the input from the brain, receives from thoughts, changes the brain instantly. So it's just like the bullet in the gun. Once you pull the trigger, that's it. You can't take it back. It's gone. It's going down range. That bullet is going down range. You can't stop it. The brain is the same thing. Whatever you perceive, you can achieve. That's why they say, whatever you perceive, you can achieve. Research has revealed that thoughts are powerful catalysts of neuroplasticity because they, unlike physical experiences, can activate neurochemicals that constantly cause emotions and behaviors, and when activated chronically, can cause emotional or behavior patterns or habits. Over time, the sustained production of certain neurochemicals, e.g., cortisol, can also change the brain structurally and functionally. Emotions, particularly when chronic, are also a prime stimulus for neuroplasticity because they, like thoughts, can motivate behavior. Our emotional responses to life circumstances, e.g., anger, stress, fear, compassion, patience, are the byproduct of established neural circuitry developed over a lifetime of feeling a certain way with regard to certain circumstances. These responses can become almost automatic as the neural circuitry and structures in our brain are modified in ways to prefer, i.e., predisposed to them, even if it's not in our best long-term interest. So basically, you can find yourself doing as we said, maladaptive behavior, even if it's against our better interest for survival. We'll do it because we've been maladaptively programmed to do it. It's like, if you say you rob a bank, you go rob a bank. You weren't born to rob a bank, but due to the social conditioning, people need money. Where's money at? It's in the bank. So you rob a bank because there's money in the bank. Some behaviors can, that's why in criminal law, they know that there's certain patterns that criminals have and that they follow. So it's it's for everybody. Everybody follows a certain pattern in life. That's how the brain operates. Your brain wants to operate to make things make sense, and so it puts things in categories. It places things into order because that's how your brain operates. And reading this type of text, hopefully, this is what the author is actually telling us and letting us know is that there's actions that we are modified to have due to the society that we're in. Past and current thinking actually mold the way our brain will think in the future. Repetitive thoughts become pattern neural activity. Even unconscious or implicit thoughts repeated enough can change the brain because of neuroplasticity. Our brain is designed to become wired to think or perceive the external circumstances of our lives the same way again and again in pursuit of survival oriented efficiency. Think or perceive something often enough, and the neural circuitry associated with the thought will strengthen to the point of becoming hardwired or internalized, i.e., transformed into pattern neuronal activity. Pattern neuronal activity changes the neural structure and functioning of the brain, often unwittingly. Doge proclaimed, this is one of the researchers that he's quoting from, proclaimed neuroplasticity as one of the most extraordinary discoveries of the 20th century. Up until the discovery of neuroplasticity, scientists believe that the only way the brain changes its structures is through evolution of the species, which in most cases takes many thousands of years. According to modern Darwinian evolutionary theory, new biological brain structures develop in a species when genetic mutations arise, creating variations in the gene pool. If these variations have survival value, they are more likely to be passed on to the next generation. But plasticity creates a new way. Beyond mutation and variation of introducing new biological brain structures in individuals by non-Darwinian means. Polish neuroscientist Jerzy Konorski is credited with coining the term neuroplasticity, although the concept was developed concurrently yet independently by Konorski and Canadian neuroscientist Donald Hebb in the late 1940s. Plasticity, Sharon Begley explained, means just what the two parts of the word would suggest. Neuro refers to the brain, and plasticity refers to the ability of the brain to change itself, to change its structure and function. Before Konorski and Hebb, it was generally accepted that the adult human brain was structurally and functionally static organ. It did not change after early childhood. The work of these two men eventually convinced the neuroscientific community that the brain continually changes throughout our lifetime. Neuroplasticity, as known as brain plasticity, neuronal plasticity, cerebral plasticity, cortical remapping, or cortical plasticity, is the neural circuitry in the human brain's ability to change and adjust as results of our environment. Thoughts, emotions, lessons learned, observations, actions, overreactions, and experiences. Just to be clear, it does not mean that our brains are literally made of plastic. It does not mean, to quote Paula Tellel, that you create your brain from the input you get. Our brain is restructured to process any new or repetitive information, and if deemed useful, especially for survival, to retain it. Let me repeat that, please. Paula Tellel, she says here, you create your brain from the input you get. Our brain is restructured to process any new or repetitive information, and if deemed useful, especially for survival, to retain it. There you go, the survival orientation of the brain again. So everything on a daily life, on your daily life, your brain is only cares about living. It only cares about surviving. Getting you through that every minute of every moment of every day, every second of every day. The very point that your heart is beating, you don't have to, think about it, but it beats, and that's all that your body is trying to control those functions that that you don't have any ability to control, and it's just seeking to keep you alive. For instance, your brain has markedly changed from the information you've read thus far in this book. Certain neural circuitry in your brain have been created or changed, and you have been slightly altered by the reading. So just by us reading, so learning is changing your brain. Reading helps change your brain. So that's why I really, suggest that, we read, because it helps us to, as I like to say, elevate our mind. There's another saying that I have, medicate, that's chewing. When you medicate, you're chewing food. And when you educate, your brain is chewing knowledge. So medicate and educate are basically, even though they're different, but they're still providing nutrient. You're getting nutrients through chewing with your mouth, and you're getting education by reading and learning through educating your brain. So educate and medicate. Brian Kolb and Ian Wishaw wrote that the brain plasticity refers to the brain's ability to change structure and function. Experience is a major stimulant of brain plasticity in animal species as diverse as humans. It, it is now clear that experience produces multiple dissociable changes in the brain, including increases in neuronal dendritic length, increases or decreases in spine density synapses, formations, increased glial activity, and altered metabolic activity. These anatomical neuronal changes are correlated with behavioral differences between subjects with or without the changes. Experience dependent changes in neurons are affected by various factors, including stress. So here we go once again, stress is having a maladaptive, having a negative effect on, the brain, the body. If the brain can't live, the body can't live. If the body can't live, the brain can't live. So, the brain, as explained by Kolstad, deletes old connections between neurons and enables the creation of new ones. Through synaptic pruning, connections that are inefficient or infrequently used fade away. Now, this is what I was mentioning yesterday. Your brain only can hold so much information. So some of these things that don't get used, your brain has to get rid of it because it needs the space for you to, when you learn, for you to learn, or when you've learned new activities or new things. So your brain has to get rid of some of the information that, it doesn't deem it necessary to hold. You're not using it and it's not helping you. And remember, your brain is a survival oriented machine. It is doing everything to keep you alive. That is your brain's primary function. It's trying to keep you alive. So it goes through the pruning. That means it's storing away or getting rid of information it doesn't need. Pruning connections that are inefficient or infrequently used fade away, while connections between neurons that are highly routed will be preserved and strengthened. So basically saying stuff that you using every day, you drive every day, at your job, if you doing computer work. So anything that you're using all the time, your brain is strengthening that so you don't forget it. So you know exactly how to do it and you don't forget it. In response to new experience or novel information, neuroplasticity allows either an alteration to the structure of already existing connections between neurons or forms brand new connections. The latter leads to increased synaptic density, while the former makes existing pathways more efficient or suitable. The brain is remolded to collect and preserve the new data, and if useful, retain it. When we perceive the new information as especially important or When a certain experience is repeated fairly often, the structural change in the brain will last, and the new information is hardwired into the neural pathways of the brain. These changes result either in an alteration to an existing brain pathway or in formation of a new one. Further repetition of the same information or experience may lead to more modifications in the connections that house it, or an increase in the number of connections that can access it, again, as a result of the plasticity. Kornorski and Hebb's theories on lifelong neuroplasticity were not immediately accepted. As late as 1970s, most neuroscientists still believe that a significant change in the brain could only occur during the critical period, i.e., infancy and early childhood. Once we reach young adulthood, neural structures and pathways were thought to be irreversible. Only areas associated with memory formation, like the hippocampus, were believed to still be malleable. It wasn't until the early experimentation on the brain plasticity during the 1970s or early 1980s that researchers began to confirm and consequently accept the neural structures and circuitry changed as a consequence of experiences throughout out a person's lifetime. Advances in brain imaging technology around this time helped evolve the research from dead animal to living human subjects. Magnetic resonance imaging, MRI, and functional magnetic resonance imaging have enabled researchers to monitor the brain's responses, i.e., regional, structural, and circuital neural activation during plasticity-related experiments, as well as conduct morphometric brain analysis, i.e., measurements of changes to the brain structures in vivo on humans. Now you got some big words in here, so some of these things you putting it together. So it's good reading though. I like it still. Be some tongue twisters here. Because of neuroplasticity, recurring thoughts, emotions, observations, actions, overreactions, and experiences effectively become neural structure. Begley explained that the brain devotes more cortical real estate to functions that its owner uses more frequently and shrinks the space devoted to activities rarely performed. In response to the actions and experiences of its owner, a brain forges stronger connections in circuits that underlie the behavior or thoughts and weakens the connections to others. Most of this happens because of what we do and what we experience of the outside world. In this sense, the very structure of our brain, the relative size of different regions, the strengths of connections between one area and another, even their functions, reflects the lives we have led. Let's read that again. Most of this happens because of what we do and what we experience of the outside world. In this sense, the very way, in this sense, excuse me, in this sense, the very structure of our brain, the size, the different regions, the strengths of connections between one area and another, even their function reflects the lives we have led. So your brain is a blueprint to how you live, the choices you make. That's why they can see, especially when they study football players, CTE. You could actually see they could see the damage that has happened to a person's brain who plays football, and not only football. It's any I believe even well, car accidents. Any shaking of your brain. When your brain is shaking in your skull, that is not good. And a lot of these, boxing, as I said, football. A lot of these people experience brain being shaken in their skull, and that leads up to CTE. Several brain regions and structures possess varying levels of structural and functional plasticity, including the amygdala, hippocampus, and prefrontal cortex. An almond-shaped neural structure centrally located in the medial anterior temporal lobe, the amygdala, which is actually Greek for almond, possesses external stimuli and reflexively determines an emotional significance and response to the stimuli, particularly when deemed threatening, which is when sent out to other regions of the brain. The amygdala is directly associated with learned emotional responses, e.g., fear, anger, affection, disgust, and is proportionately plastic. By that, I mean chronic overactivation of the neurons in the amygdala enlarges and hypersensitizes the amygdala by strengthening its internal and outbound neural circuitry. Excuse me. Which causes excessive conditioned emotional reaction to recurrent and potentially threatening stimuli. Okay, so we're on page 17, the top of 17. I think we're going to stop there. Throat's getting a little dry. Been at it for 48 minutes, page 17. But basically, we're seeing here how the functioning of the brain here and how particular experiences help mold us, help to shape us. And we have to see how we can make better choices in order that we can have better outcomes in our lives and lives of others, especially our loved ones. So this is why I believe this particular read is necessary, uh, because it helps you to think outside yourself and inside yourself, and to help you to understand, like I said before, how things work within your own mind, because they've studied the sciences. They have studied your mind. They know how your mind works, and for you not to know how your own mind works is problematic. And that's the, one of the sayings is, people perish for a lack of knowledge. That's, everybody knows that one by heart. um, and this is to give you knowledge to know how your brain operates, which makes you function and helps you to function on a daily basis. So we will end here, and I do thank you for tuning in, and have a great time until next time. Peace.